Good evening, all. Ask your friends to join the session. Good evening, Shashank, sir.
Good evening, ma'am. Shall I start now? All right. So good evening, everyone. A warm welcome. Yeah. So let us discuss a few more things about the AI agents today. Okay. So let us start. Okay. Yeah. So I'll share the screen. Yes. Yes. Good evening. Good evening. Good evening. All right. All right. So let us continue. Okay. So first of all, for the today's session, the first important thing we'll start with the thing called as webhooks. Okay. So we'll start with the important thing called as webhooks. So what are these basically webhooks is? Okay. So these basic webhooks are, which basically collect the information. For example, when we talk about two things, one is the webhooks and the APIs. Now, let us first see what is an API. Okay, then we'll go to the webhooks. Okay, yeah. So the first important thing we are discussing here. So in this image, you can see that it is connected, from one, PC to the server. This is basically from the server to the PC. And you can see here, this is basically asking for here you go and sorry, send me the data and here you go, right? So what is that exactly, in this image, what we are going to talk about this API. So API basically stands for application, programming interface or program interface, we can say as an API. So what is this exactly? This API will actually do is it is a way of communication. It's in a very simple terms. You can think of like it is a communication. So with whom we are communicating? The communication we are doing with the application. That is why we are calling it as application programming interface. So basically, we are communicating with the application. Now, when we say application, it can be any kind of application. Now, then what is the role of an AI agent here? Why AI, why I'm speaking about APIs? When we were talking about the AI agents, what is the link between them, right? So this communication with the application, right? We are doing, correct? We are doing the, communication with the application. So with whom we are basically doing here is we are basically doing the communication between the, user and the AI agent. So here we are basically communicating with the agents, right? And who is this agent here? The agent here is somebody who is actually working in the background for your, waiting for your input and I can say receiving your input or waiting for your input and giving you a answer or an external answer or whatever you require, basically giving you whatever you require. So it might be any kind of application interface. So in the background you are seeing an AI agent doing its work, right, silently in the background. For example, a use case like the open weather app. So this agent in the background, when we ask a particular weather, right, a particular city's weather or a particular place weather, what this fellow in the background, who is this agent, basically doing? So he's communicating with the servers, he's communicating with the databases, he's communicating with different people, right? So he's doing a lot of things, right? So he here refers to the AI agent. So it is basically doing many things in the background, and then it is basically giving you a certain result. So this is basically a job. This is the basic job of a AI agent through this application interface, which is the API. So pros and cons you can understand. So basically, it is giving you a certain answer to a certain request, right? And it is basically handling a lot of responses, because the same application will be handled by or will be used by many people across the globe, right? So an application cannot say that I cannot give the result too many people are using. So, an agent should not tell like this, right? So in this way, an agent will be, a multi-talented person, okay, where he can handle a lot of things. So, just for fun, I told multi-talented person, but that is how an actually agent actually functions. So he will have the ability to handle multiple requests, okay, at multiple locations and multiple times. Okay, so this is what the agent will be actually capable of. So what are the cons are typically synchronous and may require polling for updates. So next thing is, how do this API works? So just now what we have discussed is that you can see it in the picture. Okay, so we through the application interface, right, we give a certain request, right, and that certain request through the web servers, databases, right, it might be any application. So we might give through a computer, or we might give through a laptop, or you might give through a desktop, you might give through a mobile phone, you might give through a tab, right? It might be anything, any kind of request, it might be. Next thing is, what is a webhook? Okay, a webhook is basically a bot. Okay, so because obviously we have actually discussed, right? So this webhooks and APIs are basically AI driven, right? Or you can say AI agent driven, and that is a correct word. So AI agent driven, that will be a proper word. Now, what are these this particular webhooks actually doing? So these are basically are there for a specific action, or we can say something for an event to occur. So it is basically waiting for some event to happen. So when that event happens, it will react. That is what a webhook is. Okay, so it actually reacts to a certain until you raise something, right? It will not actually react. So it is only reacting to a certain things which it has to react. Okay, so it is not like an application. It is not like a normal API. This is a bit different from the normal API. Now, this is what a webhook actually looks like when it comes to the real life scenario. So you can see a webhook in action when it comes to an AI chatbot. So you already by this time you would have already understood that this AI chatbot is basically nothing but the right. It is basically nothing but the AI agent in the action. So you can see here the customer sends the request. Okay, so user sends the support query to a AI chatbot. From there, the AI chatbot can't resolve, so it sends to the webhook. Okay, so because the webhook can take the support of many things, and it will get your job done. So chatbot sends webhook request to support systems. From the support system, it takes the agents. You can say their support agent, right? Yes, that support agent is also an AI agent, right? So you can see the chain now, a group of, or you can say a chain of multiple AI agents in action, right? So support the agent notified to ticket, and he resolves the issue or the request what you have given, and it supports send back to the webhook to CRM notifying a issue. So it is basically again sent back to CRM. So CRM is nothing but the customer relationship management. Now, what is the difference between now, you would have already understood now that what is the difference between this webhook and APIs. So both use AI agents so much. Okay, they use literally so much. Now, what is the exact difference? We'll see into the terms of a difference now. So what are they? Webhooks help in sending alerts, messages from the server side application to the client side application. But the APIs is, APIs help in passing the request from the client to the server application and then the delivering back the information. Next is when is a request made. So webhooks receives call through HTTP posts from external systems only when there are data updates. So API requests without knowing if there will be data available or a response or not. I told that only in a certain scenarios only. So in a certain scenarios only, webhooks will be activated and will use things which are basically required. But APIs are not like that. We are going to, even though whether our request will be handled or not, we are going to request a certain thing and we are going to apply, or we are going to ask for a certain request to the server. So webhooks are automated calls that get triggered when an event occurs on the server side application, right? So this is in where the APIs are different from the webhooks. So APIs are adding, editing, deleting set of items instructed from the client side server. So it is basically a server side as well as a client side. So they both are different kind of applications that are designed to do different things. It's not the same thing in a different way. It is the different things actually. Okay. Then why we are talking? Because both of them basically rely on a very important thing which we were discussing, which is the AI agent. So the agent communication is very much important inside, whether it's an API or a web. So this is a very important application which we see in our day-to-day life, right? So we see this in a day-to-day life, and this is how we are going to use certain things as well. So let us go to the one more example you can see here. Okay. And between APIs and webhooks, you can see some factors like the communication type, latency, security requirements, complexity, level of control, and data volume. So these are the some of the few things which are the factors between the APIs and webhooks. This is one more example. Yeah, so I've mentioned so many examples, so many pictures. Yeah, regarding to the webhooks and API, because it is a very important concept, and it's not about it's important or not important. It's about the usage of AI agents into this, webhooks. So this proceeds automatically, full-fledged app language. So events happen, sends the data. The complex in the API is it has to the user has to send the request and then the result will come. But webhooks are not like that. They're basically something which is already programmed. It's like an automation. Yeah. So only things which need to be triggered will be triggered at a certain time and an event. This is one more example. Okay. So with webhooks and APIs. Okay. So I think you might be clear on uh, yeah. So this is one more picture which actually represents the entire scenario of which actually gives you the entire scenario of basically what is a webhook and a API. Okay. So the user basically sends the request, and the agent receives it, and he will solve the business problem or whatever kind of message, right? And again, it will be, so your webhook decides how the agent should actually respond. Okay. So because they are automation or automatically or automated, right? So the tasks are trained and pre written, okay, in advance. That is how your webhook actually performs. Okay. So next is decision making, which is rule-based agents. So first of all, let us understand about the rule-based. Okay. Now let us talk about rule-based agents in detail. Okay. So what are rule-based agents? So we are talking about agents, and we have seen multiple examples. We have spoken about what are these agents. In a different kinds of applications like the machine translation. A chatbot. We have understood. So there are many applications which even we have. We also talked about the disaster management, how the AI bots can actually function. So there are many industry-related applications which where the AI agents are actually or where it is being used very highly in the market. So here, when you see the rule-based agents, basically rule-based agents are a simple programmed agents with just a if-else type of conditions. So these conditions are where it is just going to react on certain things, respond on certain things, and it is able to write or respond to a very, a very, I can say, a very simple programming, right? A simple programming code. Like, so, it's not like what we have seen, Bardanow's attention and Leong's attention, sequence to sequence modeling. So it's not that. That is not. So this is a very simple, if else condition kind of agents these are. Okay. So it is can't learn from poor data, sorry, can't learn from new data, because these are a very simple bots and data is not actually given to it. So they are basically trained on a few sentences, and they are trained on a few factors. They are trained on a few certain scenarios. That is how these rule-based agents actually function. Next thing is how these rule-based agents actually uh, you know think and do the things. So here there is something called as a knowledge base. The components, when we see, there's a knowledge base, then there is a inference engine, then there is a user interface, then it is a rule editor, then rule interpreter, and the explanation module. Okay, so these are the scenarios which we have, right? So it's a step-by-step process. So knowledge base is nothing but all the information, all the necessary things. Okay, so knowledge alone is not sufficient, right? To do a certain things, especially knowledge, right? Having just the knowledge is not sufficient. So you also need something which can be used, or you can say which can be put into use, right? So that is in where these knowledge is basically used first of all as an inference engine. So you have a lot of knowledge, you have read a lot of things, but when you want to apply a certain thing, right? So what you will do, so you will actually draw conclusions from the knowledge what you have. That is what your inference engine is. And it also understands what scenarios that will be the user interface. Then based on the scenario, what kind of conditions you are going to follow, what kind of a what kind of a scenario it is, right? And what kind of rules and regulations we have to follow, right? And then interpretations can be done on certain rules. Then the explanation module comes into the picture. So this is the a cyclic process, I would say, right, when it comes to the components. Next is learning agents. Now, let us understand that what is a learning agent in this scenario. So, learning agent is nothing but a agent which is using some data. Okay. So, it is in a very simple language, we can say an agent, okay, which is making decisions based on some data. So it is using a data, and that data it is making a model, and let it be a machine learning model, let it be a deep learning model, it might be any kind of model. It is doing a process, it is doing some processing, and it is basically building something for taking a decision. So the very classical example of this learning agents is the recommendation systems or the recommendation agents that improve over time by learning, because it is more focused on data. So something which is learned by data, right? and which is adapted by data, which is built model by using a data. So it is data everywhere and data for everything. That is what these learning agents will actually do. Okay, so these are basically things where it is completely relying on data for everything. So next is how which AI system to use. So when we say that what kind of a system should be used, basically the most important one is the LLMs. Okay. So, but what about the others? What about the others? Which kind of an AI system which we have to use for a certain agent? So the first thing is the rule-based agent. So just some rules and regulations, right? It doesn't use any much of it doesn't use any data. Just some set of rules and regulations is basically called as a rule-based agent. Then we have something called as a hybrid agent. Basically, this combines the learning and the rule-based agents together. So sometimes rule-based, sometimes a few things on data, right? So basically, combining a certain things and then building an agent and using that kind of agent for a purpose, right? So that is basically called as a hybrid agent. Now the next thing is the LLMs. So here, when we say LLMs, LLMs are nothing but the large language models. These models can build very complex relationships. So these are extremely very powerful, and it can process. It can understand things. It can that isn't where our methods like the Barton's attention, our Leong's attention, then transformer, all these kinds of things comes into the picture when we talk about the LLMs. So this is a very small table which will tell you about learning and rule-based agents in a very easier way. Oh. All right. So next, let us see, I think probably you would have seen the, read the table. You can see that rule-based agents, the adaptability is low. For the learning agents, the adaptability is very high. And next thing is the transparency, where it is medium to low in the learning agents. For the rule-based agents, it is very high because it is only a few set of rules and regulation. That is why only for a rule-based agent, the transparency will be high. Next thing is the data requirement. So in the data requirement, you can see that the rule-based agents doesn't require any data, and the learning agents basically require high amount of data. Okay. Next is the setup complexity. So the rule-based agents doesn't require this setup complexity especially, but it is very high for the learning agents. Sorry. So next thing is AI agents, where you can see rule-based versus LLM-based AI agents in action. So this is a very good slide where it will give you the a very important aspects which can be covered. So by now you would have understood what these basically what these rule-based agents actually do, and what does this sorry what does these rule-based agents do, and what does these LLM agents actually do, right? So what how these AI agents, one which is using the only set of rules, and one is basically using the LLMs, which is the large language models. So that means it is basically using the data, right? So it is basically using a lot of data for doing things. So what happens by these two things is there is a scale of measurement. The first one is the operations. So as I told you, rule-based are basically some set of rules and regulations. But here we have in LLMs, it is more focused on, based on learned patterns from training data, right? And next is the decision process. So deterministic, same input always produces the same output, but it is a probabilistic nature because it is using a lot of data, which is what training and testing. So flexibility is it is only can handle the predefined cases because it's some only rules and regulations. So it can only handle a few predefined cases. But it is not that case with the LLMs, LLM based AI agents, because these agents can handle a huge amount of dynamic inputs as well, right? So this is in where this flexibility for this, LLM based agent comes into the picture. So complex handling is where struggles with ambiguity and unstructured data is for the rule-based agent, and excels in processing complex and nuanced information because it is a it's an agent which is using the data. So transparency, high transparent and easy to debug. Obviously, because it is very clear what are the rules which on which it is working. And LLM based agents are very difficult to debug because the transparency is very less, because most of the LLM models are deep learning models. So we are not clear on the internal layers, how it is actually forming. So learning ability, no learning is required because it is just a simple rules based, uh, some static rules for applying the or static rules to basically solve a certain thing. But it is not like that for the LLMs. For the LLMs, it is based upon additional data. More data will give more useful information, will give more useful results. Next is the computational requirement. It is very less, I would say. The requirement will be very less. But here you can see high hardware advancements or high hardware is basically required for a LLM based agent. Next is the use cases is form validation, compliance checking, rule based chatbots. Okay. And here the use cases is conversational AI, content generation, AI powered virtual assistants. So the applications are much greater or much more compared to a normal tool based agent. Now, let us talk about a goal formulation. So when we talk about AI agents, right, the first important thing which comes to mind, okay, the first important thing which comes to mind is especially the first important thing which comes to mind is the goal formulation and the task execution. And that is in where that is in where the most important aspect of the agents comes into the picture, because when we say AI agents, the expectations are very high. That means, an agent should process a lot of things, an agent should do this, an agent should do that, right? So there is a lot of expectations when it comes to an agent. And because we define an AI agent in such a way, sorry, we define an AI agent in such a way that these AI agents are also capable, you know to achieve a certain goal, right? So to reach that particular goal in a step-by-step procedure, to reach that destination where we are supposed to, do a certain task. So that is done. And to achieve this path where it has to do, each stage is also, it is capable of basically taking a decision, right? And since it is a data-based decision-making tool, it is basically we expect, right, the decision making will be really good and it takes the correct decisions according to us, because it doesn't know that it is correct or not. It is just taking a decision based upon the data. right? It is not doing anything else. It is only doing things, right? It is only doing things which it feels according to data what it should do. Okay, and here you can see that in achieving uh, you know these few things, there are two kinds of formulations where these agents do. One is the explicit, the other is the implicit. So here explicit is nothing but specified by the user, and implicit is nothing but the based on the scenario and context. It is basically trying to do things. Now, the next important thing is the goal setting. Then, we are talking that, okay, an agent should do this, should do that. So many things are there, right? How, how as a procedure or as a step, one by one, how these goals are actually achieved, or you can say that how these initial things or steps, how it is actually going to process. Okay, so that is one important thing which we are going to understand here. So the first important thing is it basically figures out your goals, right? And then it write down your goal, right? So first of all, understanding what the goal is. Okay. Sorry. Yeah, sorry, my cough. Bit unwell. Okay, yeah. Sorry. So first of all, it basically figures out the goals, and then the second important thing is it write down your goals, and the third important thing is it will consider how you are going to measure your goals. That is what I told you, that there is no such thing called right or wrong. Okay, so whatever is conclusion or inference, sorry, whatever conclusion or inference is actually supposed to be you're getting from that particular data or analysis, that particular thing or on that particular thing it is going to take a decision. So that is why I told that there is no correct, there is no such thing as wrong when it comes to the decision making, right, of a AI agent. Now that is the reason, if you see in the third step, it is going to consider that what is our goals, right? So what we require in that specific thing. Okay, so what we require in the specific thing, what we are expecting, because it doesn't know, it's a machine at the end of the day, as simple as that, right? So when it is that simple, that it is just a machine, we already know that it is just a machine, correct? Now, how we are going to measure these goals? These goals are basically measured on what we want at the end of the day, right? So on that basis, it is going to measure the right success or measure that whether the goal has been reached or not. So before reaching to that particular end, right, which is the end result. So once the goals which we require, it is able to write down and it is starting to measure, it will identify the obstacles as well, that which obstacle is coming in the way. If it will basically put out the strategies, obstacles, how it will identify and overcome the obstacles. It will put out some strategies. It will plan some strategies. Okay. So basically now when we say strategy, right? So what are the things which comes to mind? Okay. So when you talk about strategies, what are the things which come to mind, right? So strategies are nothing but, right, which which help us to achieve our goal, where which we have actually set. Now, next thing is basically the mapping out a timeline, then creating a plan, because you have the the complete guide how to if this obstacle comes, what to do, if this comes, what to do. So basically you've planned for everything, right? So it believes that yes, to achieve this goal, these are the possible obstacles based on this, right? So it is going to have a certain plan in mind, and it is going to apply, right? And once it applies, it is going to find out that sometimes things happen in a better way, sometimes the things happen uh, not in a better way, right? So on a certain situation, so based on that, it is going to apply the last step, which is the monitoring of the certain thing consistently. So that means it should be able to identify. Okay, so one such example I can give you is, for example, these credit card transactions, especially, now most of the banks, right, with the technological advancements, they're basically using these AI agents, right, which continuously monitor uh, their transaction, which they continuously monitor the transaction process, and wherever wherever there is a possibility of fraud being happening, or there's a chance of fraud being happening, it is going to identify, because it is its goal basically. This AI agent's goal is to prevent the fraudulent transactions. That is the only goal it has, correct? Now it has to do its job, right? So let us think that a person, right, a person, if he is assigned to a duty, like the same way this AI agent has been assigned a duty to protect the unauthorized illegal transactions. Now, how this AI agent actually performs now, with this bank application, right? So it follows all these steps. Okay, and in the fourth step, you can see we were discussing about the obstacles part. Now it will identify that what could be the possible areas where fraudulent transactions can happen. So it prepares a plan, it prepares a goal, it prepares a outline, right? It tries to do things, it monitors, right? I think now you would have understood. Okay, so that is why I've given a real-time example where you see these, you see this in your day-to-day life, right? Credit card transactions which is being monitored by an AI agent. So this is one of the classical examples which I can give you, which is related to the current trend and market. So this is the very important, goal formulation assessment plan. Okay, so planning the actions, environmental assessments, setting the criteria, goal specifications, object identification, and further planning. So this is the step-by-step process for achieving certain results through the goal-oriented approach. Okay, so because right from planning something to achieving something, it is there are a lot of things which actually come up in the middle, right? So now, to keep this in the in this to talk this in this perspective, it is very important, especially when we talk about planning the actions, and right from planning the action, uh, there are a lot of aspects which are involved. It's not just like we plan something, we just execute. That is not how an AI agent can actually perform, right? Because after all, when after all, it is artificial intelligence. So that means an AI agents basically requires some data, right? It requires some formulation, it requires some strategies, it requires certain things, right? It requires the knowledge, right? So all these things are there, correct? All these things are there, right? So since all these things are there, right, there are certain areas or certain things which has to be done by an AI agent actually to achieve certain characteristics or parameters. This is one more important image which shows you the goal-based agents, perspective. So the input, which is the goal interface, right? Then you have the orchestral planning, which is the workflow, task assignment, and all those things. And the third one is the specialized lean agents. So here you have 5 agents you can see in action. 5 agents who are in action, right? One is the data retrieval agent, then the analysis agent, then the action execution agent, then the Q&A agent, then the custom agent. So now see how many agents are in action, right? How many are actually, trying to, do the job on a specific, to achieve a specific goal, right? So how this specific goal can be, achieved by, using these agents. Now the next thing is basically the tool, which is the API layer. Then comes the next part, which is the shared state, which is catching, relevance, filtering, multi-agent synchrony. Then the next thing is basically monitoring the whatever based on the work we have done, right? So basically we are monitoring, right? The feedbacks, the information is taken care of, used for, and then and certain action is actually taken. So the next thing is output, where it will give the result and the delivery. Next thing is the task execution, right? Once here, goal formulation is done, the next important thing is the task execution. So planning, the first thing is the planning part, then choosing the steps, then actions to reach a certain goal. Then you have the execution part, which is carried out, sending the request. Then this is single step task where sending a notification, multi-step workflow where you are planning a certain thing, right? So this is basically done through one such example here, which I've mentioned is scheduling a meeting, right? So, scheduling a meeting, which basically understands the context or the intent, what you're trying to do. Next is it will check the calendar or the your dates where you can schedule this meeting. This will be done via APIs or the application interface. The next thing is sending the invites, which is done through the webhooks. That is the reason I have covered this APIs and webhooks in the initial stage of the session today to make you to understand when we go to the goal-based agents. So this is how these goal-based agents, how should the AI systems basically adapt these goals and actions. So uses the probabilistic reasoning. This choice involves modeling uncertainty to infer optimal actions. Then update the distributions. This choice focuses on refining predictions with new evidence. Then reassess the diagnosis part. This is where the adaptation of the AI systems comes into the picture. So this is a very simple example of an agentic AI, because agentic AI is nothing but a collection of multiple AI agents which are in action. So the goal orientation, object setting, task execution. So you can see a couple of agents there. Then you have the tool usage, web searches, APIs. Again, these are multiple agents. Then you have planning and reasoning agent in action. Each image you can see one kind of agent. Yeah, that is why I have just put this picture. It shows exactly that what kind of agents are doing what kind of task here. So self-improvement agent is doing its job. Then we have short-term memory, long-term memory agents, which are dealing with the memory management. Then we have the core intelligence agent, which are dealing with the LLM models. So this is the whole scenario and the whole picture of agentic AI. So this is basically on the strategies. And here you can see for the strategic execution, The first step is encouraging the adoption of the data analysis, then identifying the use cases where and next is selecting the areas, then auditing your capabilities, then comes your narrowing down the choices. Then the next thing is implementing a pilot project on a small scale, then establishing a baseline, then scale your AI integrations, complete the AI integrations, and build on implementation and improve. Now, let us talk about the agents, okay, which are in the form of different applications. Okay, one agent which you are very familiar is the food delivering bot. Yes. And you can see this kind of food delivering bots in many of the countries right now. In India, we are not using, but there are food delivery bots like this. Okay. So which actually deliver. Okay. So which actually deliver food on its own. So in India, we are not having this food delivery robots. We are basically using people only to deliver. So, for example, if you order it from food from Zomato or Swiggy or something like that, right? So a person comes to your home and delivers, right? So in many countries, they are using these food delivery bots. Okay, so to deliver the food, you can see the food delivery bots. So this is a classical, I really like this image. So serve robotics shake shack. So this is basically a robot which can actually deliver the food. Okay. Now, to talk about this food delivery apps or the food delivery bots, uh, you know, these particular things have that ability, right? Once the application through which they get the order, they know that yes, that particular information will be given to the food delivery bot. So these agents also perform in the background to make sure. I'll tell you one classical example. In even in India, if you see that if you order a certain item from a restaurant, right? From Zomato. So if you see in Zomato, you have certain things called as a tracking system, right? So it's a tracking system, and you can check that in how many minutes the updates, it will come, any delay and all. So this is basically done by an AI agent. As simple as that. So now you'll be very clear that yes, this is a very easy and a classical example to understand. So this is taken care of an AI agent. It's not actually a person who is sitting there and updating the location or showing the location, how much time. It's completely an AI agent. It's not a human being. All right. Now, the next thing is even this delivery thing is being done by bots. Okay. So they have these agentic systems inside which can actually track the things, because already tracking and all as a part of AI agents, you are already seeing that in India as well. But the thing is, you're not seeing these kinds of bots which are actually delivering food. Okay, that's the only difference. From India to the okay in India compared to the other countries. So next is the GitHub webhook. Okay, and there are a lot of probably a lot of people might be knowing of these GitHubs. Okay, so GitHub is nothing but a repository. So this repository basically has a lot of things. Okay, it stores a lot of things right from the programming databases, right? A lot of things are basically stored and acts as an this GitHub uh, is currently a lot of things are being used. For example, when you think of a GitHub, even your for example your ChatGPT, right? So your ChatGPT or your GPT models have the access to your GitHub. Now, why I have put this particular GitHub webhook, especially is, uh, you know, in the projects like in DevOps, okay, development operations, okay. So you will be seeing that how this GitHub actually uses. okay, or how it is actually used inside these DevOps projects. So that is where the agents build, test, and deploy. So all these things are basically done, or basically are being done by the GitHub services, using this GitHub webhook. So this is one of the GitHub webhooks which you can see in the current industry or in the current market. Okay. Now, if you see clearly, with this one such example, which is used in the DevOps. Okay. The person, this is an AI agent. This fellow Jenkins is an AI agent. So what does he do? He actually builds, deploy, and test. And again, whatever is tested, again sends back to the building phase, and again deployed, and again tested. So this is a cycle. What happens? End to end. Okay. Especially when we talk about the agents. So here you can see that what is a Jenkins exactly, right? Now, so in DevOps, especially, we use something called as a Django. So Django, DJNGO. It is not Django, it is Django. So Django is actually a framework in Python. Okay. And to deploy these Django projects in applications, AWS is nothing but the Amazon Web Services. So it is built, the project, it has been built by, so I can say AWS. Okay, so Amazon has built. Okay, let us not say AWS. AWS is basically a cloud service. Okay, which is provided by Amazon. So in their cloud, their DevOps end-to-end project is developed using the framework called Django. I think now it is clear. Now I'm clearly telling, yeah. So it will be easy for you to understand. So Amazon uses a cloud service, which is Amazon Web Services. In that, they have a DevOps project, which is built on the framework called as Django. Okay. And in that, you have a lot of AI agents. The AI agents in this project of which is built by using the Django framework are GitHub, Docker, and Jenkins. Okay, so these are the people who are there inside. So that much I will tell you so that it will be easy for you to understand. So this is the webhook. Here there, something just happened. So it is going to communicate like that. Okay, it's just a funny image to understand about the webhook. Now let us talk about the rule-based agents now. The next example is what the customer support chatbot. Now here the scenario is a telecom company chatbot answers billing questions. So if the bill contains bill not received, show bill, download link, network issues, troubleshootings, right? So you know the chatbot, right? That is why, I have also told a key differences between a chatbot as and an AI agent. So the AI assistant. Chatbot and AI assistant both are AI agents only. But a chatbot is very limited compared to a AI assistant. So, a lot of natural variations cannot be understood by a chatbot. So here you can see the top 10 benefits, okay, of using these customer support, or you can say rule-based agents. Okay, so you can just read this. Okay. So we'll just probably fetch. So what we'll do is we'll go for a, okay. So post your questions here. Okay, I'll just come back and I'll answer your questions. Okay. All right, let's just continue. Mm. Okay, so no questions. I couldn't see anything. I think it's fine for you. Okay. I'm just waiting. If you have anything, please you can post. Okay, then I'll continue. Okay, so let us see. So these are some of the benefits where this, these rule-based agents, something like a customer support chatbot can actually bring to the table. Okay, so cost efficient contextual support, right? 24 by 7 availability, answering consistently, instant responses, and so on. So you can see many benefits which it can give you. So the next thing here is the AI chatbot versus the rule-based chatbot. So rule-based will give you only what is pinpoint, what is supposed to be, what is exactly, straightforward pinpoint answers. That is what this rule-based chatbot will actually give you. But that is not the case with an AI chatbot. So AI chatbot is basically a chatbot which actually relies on multiple things. Okay, so this is one classical example you can see. So rule-based versus AI chatbot, you can see by this example. So it will only give you a few applications. It will only give a few things which so the way it communicates also is bit different from the a rule-based chatbot. So these AI chatbots are because a simple reason is that they have access to the data, they have access to the servers, they have access to the databases, right? And all these things will actually help these AI chatbots to actually, communicate with multiple things. That is in where the advantage comes, especially for the AI chatbots compared to that of the rule-based chatbots. This is one more example you can see. You'll be understanding it very much. Okay, so the answers will be very limited. It is going to only give. See here on the left hand side. So it can only help with the three things here. This rule-based bot in this scenario: order status, cancel order, and return request. But our fellow Joe has asked, when will I receive my refund? Okay, and uh, if you see clearly that that is not in the agenda for a rule-based bot in this scenario. So it only can answer in this scenario that because it is only limited to a certain rules. So only order status, cancel order, and return request. It can only answer any of these three questions only. Now, when Joe has asked for when will I receive my refund, it is telling that I'm sorry, but I don't understand your request. Please select the following options. And this fellow is again asking, he changed the request. When will I get my money back? This fellow is frustrated now. So that is what the difference between AI powered and a rule based. Now, this AI powered bot will have the access, it will have the accessibility. Okay, and it is going to search the server, it is going to search the things, it is going to give you a reply. So definitely you can expect a reply from an AI powered bot compared to that of the rule based. So this is next important thing is the Netflix recommendations. So this is also, you can see the AI agents in action, right? So a lot of people use OTT platforms. So how many of you know that the right from the suggestions, right from the personalized suggestions and personalized, based upon your sentiments about things, right? How the recommendation system works, how these AI agents in the background actually work. So this is in where these AI agents comes into the picture. It is continuously they are using data, or continuously they are using uh, you know the data which is provided by the user, and it is constantly trying to build a machine learning model, or it is constantly trying to build a deep learning model. So it is trying to use the data and try to build upon it, and over the time it is trying to personalize the, or create a personalized content for the user. That is what that is in where these recommendation systems and the role of AI agents in the background. This is how you can see that how an AI agent actually performs. Okay, so activity agent, explicit evaluation, recommendation systems, recommender agent. To show you, it is basically showing as a person. Okay, here activity agent, recommender agent, all these people are actually a machine. They are machine actually. It is a agent. It's an AI agent. Okay, so to just show you, we cannot just put a computer there. So they have put like this in the image. Okay. Yeah, so just see it. Siddesh, you're asking or you're telling me? Chatbots are helpful, but they give repetitive. Yes, because it is only, all the chatbots are rule-based agents. Chatbots, see, if you are using a AI specific agent, especially AI, when you say AI agent and AI, that is why I think somewhere down the line I was actually mentioning this. Okay, so my opinion, okay, my opinion is my opinion, right? So I told also that I won't consider a chatbot basically as an AI agent, because AI agent is somebody who has the accessibility to things, and it can actually has that goal, and it has that things which it can do, but a chatbot cannot do it. Only it is fixed. That is why I hate to call a chatbot as an AI agent, but unfortunately people call even a chatbot as an AI agent, but it is very restricted, as you were telling, and it is very limited also. It doesn't answer to a certain questions as well. So that is the problem when it comes to the when it comes about the comparing to the AI assistants and the and the chatbot, and sorry, chatbots. Can I? So, you have to make a chatbot by using a rule-based assistant. You can use any programming languages. You can use Python especially, and you have to give in some rules and regulations, and you can build. Okay, so you need some application where you can build in pre-built in. Then you can build a chatbot very easily, or it is a completely different process, because we need a platform to build this chatbot, that we don't have access to many of the platforms. So we can only build a simple rule-based agent, or if a chatbot, like how you can see, you need a particular platform to do that. Yes, that is why only I'm just telling you that. You can, but I don't know, enough knowledge will be sufficient there, because you have to be good. Because best programming language kind of right now, you can use Python. Python gives you better results. So probably you can use the Python. So yep, you can do it, but it will be a bit out of probably heavy for you to, you know, probably you can build a chatbot which is can be called as an AI agent instead of just like a dummy agent. So probably that you can try. That you can try because no use of a regular chatbot. It doesn't solve anything. So it is only predefined and pre-trained. So it is like same old, uh, you know, same old thing again and again and again. Okay. Yeah. So, oh, Sidesh, you are only asking, so what concepts need to be clear in programming languages to make a chatbot? It handle AI. You need to particularly you need to be if it is a simple chatbot, it is just a rule based. It will be a rule based chatbot. But as I told, if you want to make something which is beyond uh, beyond a regular chatbot, something which is probably genuinely we want to call it as an AI agent. It should be capable of you know exploiting, or it should be capable of exploiting everything to give you an answer. So for example, let us say a generative AI agent. So if you ask something, it should be, if it doesn't have enough training also, it should be able to explore the server, the databases, and it should be able to give you certain answers. So accessibility to the databases also should be there, right? Or if you not able to give the accessibility for its training purposes, you can only build a simple chatbot. You cannot do more than that. So people say AI agent. It is completely, a bigger picture because you need to give the access of the data where it have to, build. What you are actually simply building a chatbot is not a chatbot actually. Sorry, an agent. It's just a, for namesake, it's a dummy agent only. Yeah, because an AI agent, I'll tell you what is a clearly an AI agent. So your Google search is an AI agent. So your weather application is an AI agent. So your, it has some purpose. It has some meaningful thing. For example, your Google search, I told you. Your Netflix recommendations are AI agents. Your recommendation systems are AI agents, right? And whatnot. So these are basically AI agents. So that is the difference between a regular chatbot, just for namesake, what we are building, and what is an AI agent in reality. Yeah. Okay. You can see in the image also. That is why I have mentioned. You can see that this activity agent, this activity agent is basically receiving or taking the information from the SQL database and repository as well. If you see clearly, right? So it is actually taking from this databases as well. So that is a very important, a very important aspect when it comes to the agent systems. So this is one example for you to understand what these AI agents are actually doing in reality. Okay, and how do they, just not for a namesake, not for a namesake, what exactly they are doing. Okay, so we were just talking about the namesake agents which people are building and saying that it is an AI agent. It is not. It's like a dummy agent. So the actual agents have the the collaborations. They have the LLM models. They have the accessibility to the data. They use the transformers for the context. They use the natural language processing. They use the machine learning. They use the statistics part. They use the mathematics part. They use the deep learning part. See, that is what I'm telling. When you say recommendation system uses the database and it uses the user inputs. Okay, because here, if you see recommendation systems, it is not comments, especially when we say if you see Netflix recommendation system. It is based on like, dislike, love it. I think probably you might be using Netflix, you know. So you have options like, love, and dislike. So love is like super, I really like this. So, you know, like is like, okay, fine, I like it. So there are three options, especially. So this tells you that the sentiment analysis or the sentiments of the users towards a certain thing. So what these AI agents will actually do in the background is they produce the sentiment analysis. So to do sentiment analysis, you require natural language processing. So it has to have the knowledge of NLP systems, NLP things. It has to have the access for the databases. It has to have the accessibility for a machine learning model or a deep learning model. So this is what an AI agent is. This is what an AI agent is. It is not some chatbot rubbish. You know what we built with just some three, four rule-based things, or you know some five, six rule-based things. So that is a rubbish agent. It's not an agent actually. Okay. So think about what I have told. So in reality, as a college project, you cannot build one. You can only build one rubbish chatbot. So, because you will not have access to all these things, that is why we can only build a proper AI agent when you go to an organization, because an organization will actually give you uh, the accessibility to a lot of things to build these agents. So you have the accessibility to build a proper agent, but this is not possible. You know, when it comes to the regular when it comes to the regular things what we are building, we are saying, you know, some junk chatbot and saying it as an AI agent. So that is the reality. That is the realistic, you know. So you know that is why, you know, the examples I've shown you also as the AI agent. I've shown you that this is how an AI agent will happen in the bigger picture. That is why I have not shown you some rubbish things. Why? Because you believe that it is an AI agent, but it is not in reality. So, you know, I don't want to show you things that, you know, it is actually not an agent. Okay. So that is why, you know, machine translation is basically an AI agent. But I have shown you in a smaller picture that yes, this is how a translation can happen. So that happens in a bigger, because I have to have the accessibility for all the Spanish words where you have the English translation. So I need all the data. From where I will get this? Correct now. This is the realistic part. That is the reality part when we talk about the AI agent. So I hope you know you got a clarity first of all that not you means not you. It's like everybody that what is this agent is about. What we talk, just think that you know, thinking that you know that is an agent in reality, which is not. So that gap in understanding things should be you know compressed, or it should be you know reduced in order to understand in a better way. Okay. The next important thing, you know, one more example is this. So similar users watched by her, so recommend to him. So that is how, in a simple way, in an image, I can show you the recommendation systems. Okay. So the picture is much more bigger. The, you know, I told you know how things happen is much more bigger. This is a very small image to depict what is happening inside an AI agent, especially in the recommendation systems. Now, let us go to the next important example. Next important example, which is the goal formulation and task execution. So here you can see that the goal formulation, the most important thing here is basically booking a table for two at 7 p.m. at the Fatty Bow. So the agent understands that the user intent is to book a table and look up at a restaurant through the Google Maps via the app APIs, checking the availabilities for the through the applications, and then booking a table and giving you the confirmations. So this is how an agent works. So Google Assistant on behalf of you, it will call the uh, you know hotel or the restaurant, and it will say that hi and Google Assistant calling to make a reservation for a client. So the restaurant owner or the person who takes these reservations is aware that he's talking to an agent or a bot. In simple terms, you can say bot, but I will say that he's talking to an agent. It's an agent. Google Assistant is a proper agent. It's a proper agent, right? So I can call that as an AI agent. Your Google Gemini is a generative AI, which is a AI agent. So those are agents. Okay. Now, this is what Google Assistant does. So books the appointments for your businesses. So yes, this is one more example. That is why I've just put this image. It shows that agent in the form of a machine. Okay, so how can I help? Book my usual table. The user says, no problem. I'll reserve your uh, table and update you soon because it has the information of yours. That is an AI agent. That means something which is having the information, which is having the accessibility to things becomes as an AI agent. Now, the next thing is the smart home agents. So you can see the goal is to make the room comfortable. So based on the user requirements, based on the situations, it is going to adjust the air conditioners. It is going to adjust the, lights, right? Everything it is going to adjust according to the situation. So you can see a smart home example, which is well equipped with a device. So every device in the house is basically an AI agent. So all these are basically are controlled by a cloud system, which is called as an agentic AI. So this agentic AI controls all these AI agents, which are, performing or which are there to do a certain task in the smart home application. So this is how you can see the sensors. Lighting control is one AI agent. Smartphone alerts is one more agent. Energy management is one agent. Alarm control is one agent. Temperature control is one agent. Keyless entry is one more agent. Motion detection is one agent. Controlled irrigations is one agent. Controlled appliances is one agent. So these are proper AI agents in action. Okay. So I think probably now you would have got some clarity. Okay. That how things actually work, in reality. Now, let us see what is types of interactions in a multi-agents. So we were talking about the interaction part or the interactive things. So especially when agents are working in a multi-agent environment, the most important thing for an agent is to cooperate. Or you can say in a very simple language that work together or communicate with each other, having you know a decent behavior, right? So we say that people in a team has to communicate with each other. They has to have a common goal, right? Everybody trying to achieve the common goal. So the same thing goes for the cooperative agents as well. So it is about that these agents don't fight with each other. It's a machine, so they should not fight with each other. They should divide the tasks based on their strengths, and then it should actually do the things in a smoother way. So the examples for a cooperative agent, you can think of self-driving delivery vehicles, which is a fleet. So multiple vehicles work together to deliver packages effectively across the city. So they share the real-time traffic route data to avoid the overlaps and delays. One vehicle might take over a delivery if another breaks down. So That is the reason the communication between a multi-agent system is very important, especially especially when we talk about these delivery vehicles. So next thing is the competitive agents. So here you can see that the agents that compete for limited resources or outcomes. So the behavior is each agent maximizes its own usability, no information sharing. So the real life examples is online ad. So multiple advertising agents like the Google Ads, Facebook, etc. bid show their ads. So how many of you know this? It's a real-time bidding which happens in the AI agent competitive market. Okay. So only one wins the option to display the ad to the user. This is AI agents in action. So agents are optimized to bid smartly for cost, effective, and placement. So next is mixed motive agents. So the agents operate in environments where both cooperation and competition are required. The behavior is the user use strategies from game theory to balance the interests. The real life examples for this particular application is stock trading bots. Bots may collaborate in sharing market sentiments, news signals, but ultimately compete to buy low and sell high before others do. So this one you can use the AI agents to you know uh, use these things or do these things very intelligently. So agents may even form temporary alliances like the flash mobs to influence the market trends. So let us see the architecture of the multi-agent system. So these multi-agent systems, they need one centralized architecture or a person who is actually controlling all these things. So that person only we call it as an agentic AI. So one example is especially this traffic control system because there is one unit, one central unit which controls or which manages all these signals, okay, at different uh, things. So here you can understand that how these signals are going to be used and how these are actually the problematic area is if the central system fails or the central server fails, how things are going to be panned out. That is the tricky part. All right. So that is the tricky part in this aspect. So if 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 this works out, if that doesn't happen, the centralized thing doesn't fail, things will become very or things will work in a smoother way. But that will not happen, especially when we are talking about when we talk about this central things which control everything. So not every time these, because after all these are machines, right? So it is easy to control all the AI agents through this approach, but the problem is if central system fails, that is the only issue here. This is one important image. I would really like you to see in a very easier way. I have a few questions in that meanwhile I just see those. It is shared? No, man. You're asking me again. So, So this image will tell you this is basically a AWS cloud image. Okay, so Amazon Web Services image, and in this image you can see multiple things. So look closely into the image. Okay, so you will find a few things in the image. Just see the image. Questions. PPT, I will send you. Don't ask about the PPT, I will share. Okay. Yes. I will send the PPT, mark your attendance. Okay. Yeah. All right. Okay. All right. So this is basically a classical example of a classical example of especially an AWS agent. Okay. AWS cloud. Okay. And this particular thing talks about multi-agent system. So you can see so many agents. Okay, only a few agents are mentioned in the image. Okay, so hundreds of agents will be working in the background for an AWS cloud system. Okay. All right. Next thing is the traffic signal. So traffic management, you can see this particular image, which will you will understand. So this is where the traffic management is basically done by the AI agents. All right. Next, so this is how the traffic is basically managed. Okay, so the traffic systems, the traffic things, right, which is basically managed in such situation. So you can see here. So where the agents can capture the images, and it will based upon the the traffic. It is going to move, it is going to clear a certain signals based upon the requirement. Okay. So this is how basically an AI systems or any AI agents actually function. You can see here that the consumer uses a certain things in a home area network. So these are basically controlled, which are actually provided by multiple things, which is the service providers, internet, connections, infrastructures, all these things. So it is not just about the cloud, it is also about the infrastructures, right? Software as a service, also product as a service. So everything comes into the picture. Next is distributed architecture. So what is a distributed architecture is, it is not controlled by a central repository. So this basically is a independent, I can say agents are independent, or agents are capable of doing what they can actually want. So it is mostly they have their own capabilities. For example, those who use BitTorrent will understand this. So BitTorrent is not, so usually you can upload and download the data. There is no central repository for a peer-to-peer file sharing. So it is based upon coordination among the agents. Okay. So this is how what happens is there is a less chance of failures, and even though one or two certain areas things fail also, the entire system doesn't collapse, which is very important, especially when we talk about this multi-agent systems. Next thing is the hybrid architecture. So hybrid architecture is a combination of central as well as distributed. So this is where the things are a bit balanced, but not entirely perfect, because still there is a chance that a few things might fail, and because of that again the entire things might get uh, you know uh, not that flexible. So, smart grid management is one example. So, smart grid management is something where it is a hybrid architecture, where it is also controlled by the central repository, and also individually also they have their independent power sources on which they can act. So, this smart grid management is a classical example of a hybrid architecture. So this you can see how the smart grid architecture powers the how this AI powers the entire systems. Sorry. Okay. So let me go to the next part. This is one more energy where how the AI agents are actually applying these grids to the renewable energies, applying the energies, energy management, maintenance, all these things, how they're actually doing. Okay. This image and this image tells you a lot of things. So how these AI and IoT devices are managing this. So smart houses, smart transport, right? Solar power, thermal power, right? And this is how the agents in the background of the, where it is basically controlling the things and managing the things. All right. Now, let us go to the applications. And coming to the applications part, you are pretty much aware that, yeah, yeah. So now let us see the examples, or we can say the use cases or applications. Okay. So when we talk about the when we talk about this smart grids, sorry, applications and the multi-agent systems. And one such application is the smart grid. So smart grids are controlled by sensors. All these sensors are basically called as an agents. So smart meters and control systems. And the goal is to basically balance the power supply and demand in the real time. So the example is when a region's power demand spikes, agents reroute the power from other sources automatically to avoid blackouts. So this is a one classical example. You can understand how these multi-agent systems will do the right thing at the right time. So autonomous vehicles, each vehicle is one agent. Again, traffic lights, road sensors, all these are basically AI agents. So the goal is to safe and efficient travel without human intervention. So the examples is vehicle to vehicle communication allows the cars to form platoons optimize fuel usage, and prevent collisions. This is what it can actually do. Next thing is the healthcare systems. Here the agents are doctor bots, patient monitoring agents, diagnostic tools. So these are the agents which are there. So basically these provide coordinated patient care. The examples are a wearable health agent alerts in AI diagnosis agent, which schedules the test via a hospital scheduling agent, all without a human intervention. So this is where this is certain examples where this is a certain example, especially when we talk about uh, you know when we talk about in these AI agents, particularly in the healthcare sector or the healthcare domain. Next is the e-commerce and auctions. So the agents are buyer bots, seller bots, negotiation engines. So the goal is to automated price negotiation and order placement. So examples like the Amazon dynamically adjust the product prices based on the competitors' bots behavior and also market demand. So next example, I think you would have understood very clearly. Now the next thing is the disaster response. Let me check. Yes, absolutely, you're correct, Sadesh. We use agents in our day-to-day life. If you are using Amazon application in your, in your life, means you are using an agent. As simple as that. Because you have recommendation systems, you have support systems, you have everything which are run on AI agents. So it is basically we are living with one. Yes, perfect. Yes, you got it right, 100%. Now you got a clear picture, I think, about what is a AI agent. All right. So if you have not marked it, please mark it. Okay. Yeah. So the next example, in this case here, you can see that for the disaster response, and for the disaster response, you can see the drones. Yesterday's PPT. It will not work in weather forecasting due to unpredictability. Yes, but most of the predictions are actually right, Harsh, actually, to be fair. I'm really seeing, no, because I'm, a bit of a weather freak. So I just check a few things, I depend upon, Google's weather, I depend upon a few, weather applications, especially Google. Uh, I feel 9 out of 10 times it gets it right. Definitely. There is a slight unpredictability that will be there in many applications. We cannot forecast 100% correctly. We cannot forecast anything 100% correctly. Exam will be tomorrow. Sorry, not tomorrow, Monday. It will be on Monday because today is day 14, no? Sairaj. So tomorrow, Saturday and Sunday, we don't have class. After that, Monday we'll be having. Monday will be the last day. There, I think last 45 minutes, I think 1 hour, maximum 45 minutes to 1 hour. You will have in the first 1 hour, I'll discuss a few concepts. Then we will go with the test. Okay. Okay, sir. Yeah. All right, Sairaj. So have you marked the attendance? Please mark everyone. Okay. Yeah. So let us continue. And in the disaster response management here, the most important bots, especially or the agents which we are using, is these drones, which are the rescue bots, communication systems, right? And the goal is to locate the survivors, assess the damage, and deliver aid. So the example is drones map debris, ground bots, rescue, trapped people, and all agents coordinate to avoid duplicating efforts or entering dangerous zones. Okay. So let us see about the ethical considerations in the AI agents. So let us understand that what are the ethical issues which can occur when we talk about AI agents. So the key issues here are autonomy versus the control, bias and fairness, transparency, accountability, informed consent. So these are some of the ethical issues. Tomorrow probably we can see, okay, because we need to talk about a few things as well. So these ethical considerations we can see tomorrow. So in the meanwhile, if you have any questions, you can probably ask me. Uh, but in back AI agents are there. Yes, yes, that is absolutely true, Siddesh. Yes, exactly. You got it right. You got it right. That is what happens in the background. Yes. So any questions you have, you can ask. I'll share the PPT. Okay. Just be with this. I'll share it. Okay. Just give me a moment. I'll answer your questions. I've shared it. Shared the PPT. You can just download it. Yep. So this is 14. Sir, how difficult or easy is to make forms? Siddesh, I've answered that question already. I've actually told that in very detail, Siddesh. Sorry for not answering again. In detail, I actually, just see the video, just go back a bit. So you will, you'll definitely, find a sweet spot where I have discussed that. I have actually discussed in very detail. So just please go back the recording, okay? So it's easy to mark. It's it. Yeah, the recordings are uploaded to the LMS. So PPTs, LMS, everything you can. Sorry, PPTs and videos you can actually watch it again. Uh, so. So it's a typical question. That is where there are some ethical considerations also when we talk about AI. That also need to be considered. So yeah, it's your question is somewhere in the middle actually. It is, I will say, it is true, or and also I will say it is wrong, or it is not possible also. Like it's not possible in the sense it's not like not possible, but it is definitely, it is our responsibility to not to do that. Okay, so that one I can make, I can tell you that. All right, then, ma'am. Yes, yes, I'm done.
Yeah. Thank you, sir. Thank you so much.
Sure, sure.
We'll meet again by Monday.
Yeah, yeah, ma'am. Yeah.
So, dear students, as sir informed, like only for 1 hour the class will be, the other 1 hour will be for assessment. Okay. Request everyone to join the session by Monday. As Saturday and Sunday we don't. So again we are meeting on Monday. Okay. Yeah. Then fine. We are winding up. Good night.